And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be dealing with this errant antenna. So fitted the antenna back in November of last year, and to be honest, its performance has been woeful. So with the APRS LoRa experiments I've been running, to be honest, I'll be lucky if I get 2 miles of range out of this compared to maybe 20-25 miles from the attic mounted antenna. So all right, that's got the benefit of height, but it's also shielded by the antenna, this by the attic, by the roof, but this is shielded a bit by the houses. But honestly, its performance is awful. Sometimes I've not even been able to get a packet from just at the end of the road. Yeah, let's have a look at that. First thing I think we need to do is go into the workshop, actually sweep the antenna and make sure it's not the cable, because I've used this antenna in the past. It's probably 30 years ago, but it used to perform a lot better than it is here. So let's get the Nano VNA and give it a sweep, and then take it down, maybe connect a dummy load in there and see if that measures good, and that will eliminate our coax. So let's get started. Right, well, I've got a freshly calibrated Nano VNA connected to the antenna. As you can see here, I've done a sweep between 200 megahertz and 550 just to prove it. I shall do it again. I've set a marker at 448.5 megahertz. It was nearest I could get to 450, which I think is where that antenna's centered. And yeah, it's horrible. Look at where the return loss is. We've barely got a dB of return loss there. It wants to be better than -10, certainly better than -18, really, and it's just horrible. The minimum SWR is 15 to 1 at 546 megahertz, a return loss of -1.1 dB. So this is worse than 1.1 dBs of return loss. It's utter junk for some reason. Whether that's our coax or the antenna itself, I don't know. So yeah, I mean, I used this antenna, it probably was back in the early noughties or late 90s, certainly on the 70 centimeter ham bands, with great results. So it's either broken, full of water, or doesn't like being attached to a metal mast. I thought of that while I was just out there looking at it a moment ago when I was filming the intro. I wonder if it's supposed to be isolated from the mast, and that's upsetting it. But this, to me, this looks like an open circuit bit of coax. So I wonder if our coax has had it. So what I'm going to do is I'm just going to go up my mast, disconnect that coax and put it into a dummy load, and then we'll run this sweep again. Right, let's do that. So just before I go outside and do that, I've just done a sanity check. Again, the same sweep, but I've connected a 50 ohm load to the output of the VNA. Oh, look, it's smack bang in the middle of the chart. Look at the return loss. What have we got? The worst is minus, what, 39 dBs. So, yeah, I mean, we're in the realms of noise down here. Anything, you know, getting on towards -20 would do us for an antenna, really. But yeah, look at that, bob on 50 ohms. So I know my calibration is right. And look at the SWR down here. It's 1 to 1-ish all the way down. So yeah, so there we go. I think that proves the VNA is working. So it's either a problem in the cable of the connector or in the antenna itself. So let's get that cable disconnected and put a load at the other end of the coax and go from there. Right. Now, I know what some of you are thinking. You didn't put any tape round that, and you're right. I didn't weatherproof that connector. N-type connectors are supposed to be watertight. I did, however, grease it up with some dielectric grease, so it should be good. Right. I'm going to be using this dummy load just because it's got an N-type on it. clearly we don't need 250 watts. Right, let's go and run the Nano VNA. Hopefully it's not the coax. Back in the workshop, Nano VNA is still set the same, so this is what it looked like last time. Let's have a look and see what it's like with the dummy load in place. Sweeping. Oh dear, no change. My coax is faulty. Blast. I don't think I have any more. That's going to mean a new piece of coax, unless I can actually take that apart and find out what's going wrong with it. The other thing is there is an adapter in there because it's an end-to-end coax, so I just wonder if we just take that adapter out and fit another just in case that's somehow open circuit. Let's have a look at that. Right, belt and braces. I've just taken the adapter out of circuit and replaced it, so let's just push sweep again. Oh, well, yeah, okay. All of a sudden we've got a decent reading. So are my coax and antenna actually all right, and it was just a nasty adapter all along? Let's go and let's go and reconnect the antenna, remove the load, and see what return loss we get. Bizarre. That's a result, isn't it? Could it just be this crummy old N-type to SMA adapter that's on the end of the coax back in the workshop that's at fault? Looks very much like it, in which case I shall yeet it up the garden in a minute. But let's just reconnect the antenna and go make another measurement with the VNA and see where it's actually resonant, if you like. So yeah. Right, disconnect. Ooh, blustery. Dummy load. Reconnect that. I'm going to check the connector. Dry as a bone, clean as a whistle, so that's good. Let's reconnect that to the antenna. I'm not going to put it back up into the raised position just yet. Oh. Let's go and make another measurement. Right, so antenna reconnected. Here we go, sweep. Okay, so where is our minimum VSWR? At 424 megahertz. So let's just zoom in on that area. So let's go, where do we want to go? Let's go 420 to, I don't know, 450. And let's sweep that. And something's gone, 4,500 megahertz. Yeah, that's going to have crashed Nano VNA. Right, let me just start that back up and we'll do it again. Yay! Right, let's got that going again. Right, so we want to connect to device. There we are. We're going to do, what do I say? Let's do 420. Get it right this time, otherwise it'll take forever. 420 to 450 megahertz. There we go, span of 30 megahertz. Sweep. There we are. So this is acceptable return loss. 435. Funny enough, actually where it's supposed to be, it's climbing at that point. So interesting. Very interesting. So yeah, our best is down there, but we're up here anyway at 440. minus 15 dB of loss. So the problem was with that wretched adapter. Interesting. I'm just going to drop this down to 300 megahertz and see. In fact, let's go down to 2 meters, 144 megahertz to 450. See what it looks like down there, just a matter of interest. Yeah, it's not particularly good down at 144. Minus 5, no. Look at that, 220. It worked really well in America, and also for DAB in the UK. That's why we don't have 220 75 centimetre band in the UK. If you're abroad, it's because we use it for digital radio broadcasting here. What's that there? Where's that point? That's 312 megahertz. Don't know what's on that bit. And down here we've got, yeah, 420 megahertz. So anywhere under here is rather good. So yeah, as you can see, there's our SWR plot here. So we want to keep it sort of below about 2 to 1. Anyway, shame it doesn't work at 144, but never mind. It's largely academic because I'm going to take that antenna down anyway. I've replaced it with what's in the attic, and I'm very happy with how that's working. So what I'd rather do here is have a proper ham radio antenna on there that'll do VHF at 2 meters for me as well. So yeah, I think that's what I'm going to do. I've also got a telescopic mast in the garage that is no longer in use anymore, so I'm thinking that fit nicely on that bracket, and I could get a bit more height and then in the same instance lower it to make it wife and neighbour friendly when it's not in use. My wife was very kind enough to buy me a new antenna for Christmas, so that I think is what we're going to do. Right, it's the following day. I think the next thing to do is to take that antenna now and make readiness for the new antenna. So here's the new antenna that the long and suffering Mrs. Dawes has bought me for Christmas. It's a Diamond X300. Dual band, 2 meters and 70 centimeters, high performance vertical antenna. It's collinear, dual band, and quite some impressive gain figures. We've got 6.5 dBi on 2 meters and 9 on 70 centimeters, so it should be a good performer. I've had some great results with diamond antennas before. I've got one on the car that's been there for years. It's all bent and buckled these days, but it still performs really well. So next thing is we're going to need to put this together because some assembly is required. Here's the antenna. Selection of screwdrivers, which I think may help. I think there appears to be some instructions in there, so go ahead and get it out. Mounting tube, top bit of the element. I chose the version with the N connector on the end there. Our mounting tube. The important thing there is to remember to put the coax at the middle of the tube first. Those will go around the mounting tube and attach to the mast. Where the mast tanks. These instructions cover several different antennas, so we need to find a bit for the X300. One, connect upper and lower antenna parts. Right, this is the just wondering why I've got no end piece. What's in there? Nothing. Okay.
Let's extract this from its bag. Ah, it is a solid sort of silver tip to it. There's a label on here. Let's just move that around there for a second. Do not pull out the element more than this length, otherwise the element may be broken. Yeah, we don't want to do that. So, connect upper and lower elements. So, pull out of the way. Set a gasket holder here. Now I take it that's our gasket holder. So let's just move the gasket down to there. There we go. Okay, it's in place. So now apparently I have to join the two elements, and it shows that one coming out. But how do I insert that up into there? Because there's a screw connector in there. Put the lower element into the element joint bracket thoroughly and fix RT. Okay, and after fixing the element into the joint bracket, fix upper and lower outer shells with the outer shell joint bracket as shown in figure 2, which is there. Well, how am I meant to be able to do the screw up in there? You can sort of see down in there. Can you see that? There's a connector in there with a screw on it. Ah, I think it moves. It does. There we go. Right. So we've got to join the two together. Okay. Join the two elements together, curl that red thing up. And then you slide that back over there, and this overlaps. And yes, I see. Now what I'm going to do is I'm just going to go inside and get a little bit of dielectric grease in there, just to waterproof these threads a little more. Right, bear with me. Right, got a bit of the old Superlube dielectric grease, so there we go with that. Slide these two together at the right points. Do that up. Oh, grease everywhere, look at that. Oh, there. It says I need 2 spanners just to do this section together. So it's the better I haven't got the right spanners. But I have got some adjustable pipe wrench type things over there. So I had to do some maintenance to the roof earlier, so yeah, right, that's all gooey and horrible. Throw that away, clean myself up, and I'll be back. I don't suppose that spanner's going to be big enough, is it? No. I've only got one pair of pliers here. think that's going anywhere. Get a bit around the top as well, shall we? That should keep the weather out for a while. Grease getting covered for now. Right, what do we do next? That's part 3, part 4. Line them up. Next dog saying hello. Attach 3 radials as shown. Radials. Radials? Ah, radials. Another bit of instruction in there as well. A little bit of instruction, see, it's being Japanese. Partial change of the assembling. Okay, so that's just about the pipe bracket. Ah yes, I see there's a slightly different, it changed the way this works slightly. Right, well, that's good. Left that bit of plastic on. That way, I hope. There we go, so let's fit the radials. On camera? Yeah, just about. Sweet. Great. So, got a small, I think I'm going to have a spanner that sizing, so maybe it's the pipe grips again. Nip these little lock nuts up. Good old Nipex. Right, so that's the antenna in the main assembled. So I've got to pop my coax through there. That then slides over the bottom there. We'll do the coax connector. Again, there'll be plenty of grease. Danger, watch for wires. You could be killed if this product becomes near an electric power line. Read instructions here. We're not anywhere near any power lines, so that's good. We've got to fit those 2 bits on there. So let's knit those up now. I have to say, this is really quite nicely made. That's good. Let's see if we can find a spanner for that. Looks to be 10mm. Yes. remove the plastic cap on the end here for the end connector. They do a PL259 version. Not very good at UHF though, is it? So I prefer the N. Okay, that's my coax. That's my pipe. So that needs to go up there first. Don't forget that. Now, lots of people love a bit of self-amalgamating tape around here again. N-type connectors are waterproof. So they've got a little rubber seam in them. So it is belt braces to put that on there, but I think it's fairly well protected in the tube anyway. So I'll have a bit of dielectric grease around it. New threads, just to get consistence, and then screw it up. This part where the connector's crimped on is also water sealed because it's got a glue lined piece of heat shrink around it. And I'm just going to nip that up. There we go. Right, put the tube back on the base. Well, it's reverse on first. There we go, we've got the two holes lined up there. There's a flat washer and a spring type lock washer on there. I've got this wrong. That screw's got a grub screw in it for holding the bottom, so I think I'm a third of a hole out. I thought when I first glanced at that it was the right position, but it isn't. So does that mean I've got to go that way? Yeah. That's it, I've got two threaded holes now. There's obviously a grub screw in that other one that holds the antenna together at the base. Right. There we go. What a super thing. Okay. Oh, caught on the clothesline. Actually, it's not a bad thing. Oh, no, maybe it is. Right. The next job is to go and sort the mast. Right. So this is my replacement mast. As you can see, it's a sort of telescoping thing. So if I undo that, you can sort of start telescoping it upwards, and it is very tall. So the only problem is if I keep telescoping it, it comes apart. So what I'm going to do is just nip that one up there, and about my person I've got a Sharpie, so I'm just going to mark up on the pipe round there with a Sharpie the maximum height, because obviously when there's an antenna on there I don't want to be having a disaster and playing javelins with it. So there we go. That's that one, and just repeat for all the sections really. Does that as well. Falls inside, but that won't be an issue with the antenna on the top because the mast brackets will prevent that from occurring. Sorry, the antenna brackets where they clamp to the mast, I should say. There we go. Right. Now my mate Matt's got one of these in his garden and he's had it up for years, and he does say the plastic fittings do sort of erode over time in the sunshine. Not that we get much of that in the British weather, but hey, I think we're getting close there. Right, there we go, that's marked up. Right, let's go and have a look at that mount, take that old piece of mast down and see if we can get this to be good enough. Right.
Okay. I was a little bit worried these brackets weren't going to be big enough, but I think they're going to be super. So let's put some nuts on that top one. The beauty of this time as well, I haven't got to do all that ratcheting business because it's actually sat on the ground. Next job is fit the antenna onto the mast. I'm going to do that by sitting on the roof because, yeah, it's going to be far easier than trying to move it all up there at once. Right. Okay. Right. There. So, lovely view from up here. So, oh. That's how I want it. I think we're going to have a problem with mast width. No, we're not. We'll be all right, I think. Yeah. It's getting locked up there. Have I left my spanner down at the bottom? Nope, it's there. Right, I just want the bottom of the antenna above the top of the mast, so it's sort of like that. There we go. The idea is to try and keep these sort of U-bolts evenly spaced at all. Because obviously if you do it one side more than the other, you end up with a centre point pinching the mast perhaps earlier than it should do. And you really want to just touch that mast. You don't want to do it up so tight that it folds it flat, because then you're in trouble. Excellent. Well, I suppose the next thing is to put it in the sky and see how high we can go. I won't leave it there because of wives and neighbours. Right. So, yeah, let's just take that one up. That'll do us. Blow me, that's quite some height. I'll just yeah, height is might. Let's take the camera out the front and get a shot of that. I don't know how obtrusive that's going to be really. I'm not going to leave it up that high anyway because yeah, neighbours, so I'll lower it back down, and if ever I need that bit of extra DX, I can take it up into the sky. Right, let's go and have a shot around the front. Well, there's the good news is it's sort of fairly invisible. I
tell you what, it's leaning slightly, and that's all due to the fact that the one side of the antenna itself, where the pipe is, I can zoom in on that, wobbly footage coming, you can see it's obviously the centre of gravity is slightly to the left there, and that's just causing that gentle bit of tilt. But it's only a temporary arrangement. I'm quite pleased with that, really. Hang on. Yeah, it's up there where the TV antenna is. The TV antenna's a little bit lower, but that's okay. I think that'll be wonderful. Right, so final confirmation, of course, is let's go and put the Nano VNA on there and see what it measures like. Right, Nano VNA saver is up and running. Connect to device. There we go, and we want to go between 140 megahertz, should we say, 140 megahertz. And where should we stop? 470. Span of 303.3 megahertz per step. We might improve on that in a minute. I don't know. Let's put it to 2. So sweep. Let's see how we look. Oh, right. Okay. So there is our first dip around there. So VSWR there is pretty good. VSWR at marker 1, which is the red one, 144.95. So I want 145. So yeah, that's pretty good. Return loss of minus 19.387. Lovely. Q of 0.18. That's good. What do we got here? Interesting little peak there. 200 megahertz. Okay, might get a bit of DAB on it. What's that one? That one is 236, and what we're going to do with that. And here's a hell of a dip. Look at that. So return loss of getting on for minus 40 there. 400 megahertz. So that's amazing. Return loss of minus 40 dBs. 0.024 Q factor. Very narrow dip. So where are we in 70 centimeters? 434. We're here, aren't we? So we've got this bit here. Oh, we're always around minus 20, look. So look at the SWR in our 70 centimeters band here. Pretty good. Our point there is 432.239 megahertz. That's a VSWR of next to nothing. Q factor, look, 0.049. Return loss of minus 32 dBs. So that's just cracking. So that sort of proves that out. Yeah. Excellent. So we can use anything sort of underneath. What's minus 15? Ooh, come here. There we go. What's that at? VSWR 1.3 to 1 there, and that's at 143 megahertz. And yeah, so we've got quite a usable bandwidth. What's that? 2.4, a bit high. Be here, sort of thing. There you go. What's that? 1.8, just under 2, and that's at 148 megahertz. We're never going to be up that high. So yeah, what a super antenna. That's proved that out. So there we go. Excellent results with the antenna aloft. I suppose it'll vary much as I bring it back down to a more stowed position, if you like. But that's great. So we've now got proper 2 meters and 70 centimeters antenna working at long last. So I'm looking forward to using that as time allows. But I know what you're saying. What about HF DOS? Well, tune in very soon here at Doz's Television Workshop, where we'll look at another stealthy, retractable HF solution. See you soon. Bye. Section and just extend it. What happens is when you get to a certain point it comes apart. Obviously I'm not going to leave it up all the time, so I'm just going to spend a couple of minutes and mark sort of the maximum height that I can have. Oh, let's do that again. Only let's not do that again. This bloody thing as well.